Okay, so here we go. We're starting with chapter 2. This is the first section of it. It's all about equation solving this time around. Okay, so for those of you who have a strong background in equation solving, you will love chapter 2. It's going to be a piece of cake, to be honest. First thing I want to do is just notice the format once again. It's going to be very formal, but I want you to at least understand what we're covering each sections. At the end of the 4 hour, however, I will have a focus question for you. Ideally, I will have a focus question for you before we start the lessons, but anyway, I forgot about it. So don't worry, I'll make sure to remind myself next time. But we have 3 focus questions at the end of this. I'll show them to you. But what are we talking about today? Writing equations. I hope you have your notebook out just in case you need to take down some notes. You know what I'm saying? Okay. Anyway. Look at our purpose for today. We are really doing a conversion from verbal to, not expression this time, but equation. That's the main difference. And vice versa, we're doing equation back to verbal. See, the way I talk to you right now, that's I'm verbalizing. And when I say 2 times x plus 5 equals 3, for example, and you write that down as an equation, that's converting from verbal into an equation. And vice versa, when you read your equation over the phone to someone, that's you're verbalizing it, okay? But before we start with that, I want to talk to you about the 4-step problem-solving plan. What is that all about? Well, it's a systematic approach trying to help you to solve a word problem effectively. What does it mean to be effective in problem solving? Well, every time I give you a word problem, the first thing you guys will probably do is forget the words, just look at the numbers, right? Is that true? But that's not the case, though. You skip the most important things. You got to read the problems, really. So the first thing you got to do for a 4-step problem-solving plan is read it. Yes, please, if you want, or if not, you can also write it at home. Okay? If you can't complete it in class, you can always finish it at home. Okay? You don't have to wait for me, or I'll have to wait for you, or anything like that. This will be online. And of course, after you are done reading and exploring, what should we do next after we're done exploring?
Solve it.
You see, you skip one step already. See, you jump right to solving without having any clue on what do I use to solve. Yes.
Think it out.
You think it out loud. Or you're planning, right? Very good. So after you're done reading it, you want to start planning. What operation am I going to use here? Should I be adding, subtracting, multiplying, dividing, or any combinations of the above? Okay, so planning phase is very important. This is where you start defining the unknown. Like, what is it that I'm trying to find out? So this is the planning part. And of course, once you're done with planning, you will start doing what? Solving. Now is the time you to solve. You solve for the unknown, okay? Whatever it is that you're trying to look for. And last but not least, a lot of you actually stop after step 3. But you should know better that after step 3, the most important step 2 is what? To check your work. And notice I always ask you to do this on your test, but not many of you actually, do what I ask you to do. Therefore, we have the results that we have, So, explore, planning, solving, and checking. That's the 4-step plan, okay? Of course, not all of you will follow this all the time, but I want you to form a habit of using the 4. The big 4 in a sense, okay? So that's what 4-step problem-solving plan is all about, okay? Now, if you take a look at the next one right here, next part is defining a variable. When do we define a variable? Do you know? Why do we need to define a variable, and when do we need it? Yes?
When it's really big.
Not necessarily something's big. What is the variable used for? What is it replacing?
Number.
Yes, technically replacing the number, but the number that you're trying to find, right? So can we just say that you are trying to figure out what the meaning of it is, in the sense that when you're trying to define a variable, you are giving meaning to the unknown. Okay, that's what you're really doing. When you define a variable, you are giving meaning to the unknown. Okay? Because if you just put down h as a variable, you might want to question yourself, what is h representing? You have to give meaning to it. So that's what the definition is all about, defining a variable. And we're going to be doing that a lot for this particular chapter. Okay? And the next one that I want to talk about is a formula. Do you know what a formula is? Please do not spit back A equal the area of rectangle is length times width. The area of the square is side times side. That's not what I want to hear.
Like,
What is your definition of a formula?
it's like an equation that's an equation to use to solve for a certain thing.
Okay, you almost get there. Very good.
An expression with variables inside of it.
Well, we have all the above. Very good. But technically, can we just simply put a formula as simply just a rule describing a relationship of like certain variables, really? So if we can shorten that for a bit here, a formula is nothing but a rule. We have rules for everything, don't we? We have a rule to find the area of a rectangle. We have a rule to find the area of a trapezoid, of a circle, perimeter, such and such. And that's what formula is describing. It is telling you what the rule should be, and you should be adhering to the rule. You should never break it, right? If I asked you to find the area of a rectangle, length times width, but you ended up with length plus width, then you just broke the rule. Then you will get the wrong answer. So a rule is something you must stick to, and that's what the formula is. You have to stick to the formula, or stick to the rule. Okay? All right, so as we continue on to this lesson right here, I want to show you a quick translation here so we can actually get this done. Let's check this one out. Here's a sentence. A number b divided by 3 is equal to 6 less than c. This is not an expression anymore. This is a sentence describing an equation. What word gave it away? How do you know this is an equation and not an expression? We talked about the difference between the two before, right? Yes? Huh?
Number?
Not necessarily. What tells you that this is an equation, not an expression? Yes?
That it is equal.
Yeah, thank you. An equation has an equal sign. And notice that right between the sentence right here, you notice that you do have the word equal there. So this basically sections off the two sides. Here's the left-hand side and here's the right-hand side, right? So what do we have on the left-hand side? A number b divided by 3. How do we write a number b divided by 3? Yes?
B divided by 3.
Huh?
B divided by 3.
Yeah, so can we just write like that? It's pretty easy, right? And on the right-hand side, how do we write 6 less than c?
Minus C.
Notice you said c minus 6 and not 6 minus c. Why is that? What did I say? What did I tell you about the word last day? Yeah, you always switch. Very good. So because of that, you are switching the 6 and a c to get this. And that's your final equation. Is that hard to do, guys? I hope it's simple enough, right? Okay, so let's see if you can actually come up with the next one for me here. And tell me what the answer to this one is. Go ahead and translate this sentence.
Can we write it?
You don't have to. It's online anyway. Like I said, you can certainly fill in later, but I really want you to focus on this. 15 more than z times 6 is y times 2 minus 11. Is this an equation or an expression? Let me read this carefully. Notice someone said expression. 15 more than z times 6 is y times 2 minus 11. Did I just give away something?
Yes, it does.
Yeah. The word is, even though I don't see the word equal, but the word is means equal already. So technically, that word right there is equal. So we know that this is an equation or an expression. It's an equation this time. Very good. So how do I write 15 more than z times 6? Yes?
6Z plus 15.
Okay. Notice she said 6z plus 15. She did not say z6, huh?
No, 6Z.
Because we know how to write our coefficient, right? Coefficient is in front of the variable, not the other way around. So even though I say z times 6, many of you are probably going to be tempted to write something like this. This is not wrong, by the way, but it just doesn't look right. You know what I'm saying? It's not wrong, but it doesn't look right. So therefore, I want to write something that looks good, looks nice. And this is a good way to write z6 by putting the coefficient in front and also the constants. I know it's just a constant 15 more than z times 6. The reason I can write it like this instead of like this is because of what property? Do you know? Yes. The commutative property, because I switch position. Works just fine for addition, isn't it? So the commutative property allows me to do something like this. I took care of my left-hand side. What is my right-hand side going to look like? How do you write y times 2 minus 11? Yes.
2y
Okay, 2y
minus 11.
minus 11. But please, however, when you try to read this back to your friend, do not ever say 6z plus 15 equal to 2y minus 11, right? What are you missing there? When I say 6z,
6 times.
yeah, you have to say 6 times z plus 15 equal to 2 times y minus 11. You've got to have that in between. So often, when I have something like this on the test, you know, instead of writing a times b, I just write like this. But implicitly, you should know that's a times b, right? And I said, okay, a is 5 and b is 6. You should know it's 5 times 6 is 30. But some student, guess what some student will do? A is 5, b is 6. Therefore, my number is 56. Okay, yes. So therefore, I force you to say this every single time. It's not AB, it's A times B. Okay, is that clear? I hope so. Okay, good. Check this next one out. Tell me, what is the answer? Translate this sentence into an equation. A number C multiplied by 6 is equal to 2 more than D. A, B, C, or D. Just keep your thoughts for a moment, and then I'm gonna, you know, like we're gonna be in sync, and you tell me what the answer is, like right away. You know, like right away. You know, I have to sing and dance right now. Are you okay? All right. Okay, ready? 1, 2, 3. What's the answer?
A.
Indeed. Very good. You can kind of see that too. A number multiplied by C, 6. 6 by C, there it is. And then on the right hand side is 2 more than D. There it is. More than means plus. Perfect. Check this next one out. Be very careful. Think carefully before you say it. 3 less than a number A divided by 4 is 7 more than 3 times B. Okay? 3 less than the number divided by 4 is 7 more than 3 times B. Okay, ready? Okay, here we go. 1, 2, 3. What is
C.
Indeed, very good. How many of you here thought the answer should be A? See, you thought that was A, but if you read it carefully, watch what happened. It says 3 less than. So you know that the 3 has to be back here, right? And then less than mean minus. Whatever that is, it's a number divided by 4. Number divided by 4. So there is your misconception there. Okay, for those of you who thought it was A. Be careful when you read it, okay? Okay. Take this next one here. And we're going to talk about the 4-step solving plan. And so let's attack this problem we can. Let's use our first step. When I give you a word problem, what do?
Read it.
Read it. A jelly bean manufacturer produces 1,250,000 jelly beans per hour. That's a lot, right? Okay, how many hours does it take them to produce 10 million jelly beans? Okay, so you have the problem, you explore it, you kind of know what they're asking you to do, and the next phase now is to do what? To start planning it. Okay, so here's the planning phase. When I plan, I start asking myself, what is it that I need to solve for? What am I solving for? Okay, how many hours, right? So this is the unknown, isn't it? Every time I mention the word unknown, you should have a variable in its place. So the best letter to represent hours is what?
H.
H. Okay, or T for time you want to, but it's better off to say H. H is what? See, this is when you define it. Give the meaning to the unknown. Hours what?
Per.
Needed to do what?
To make 10
To make 10 million jelly beans, right? You give it a specific definition so that when you go back and question what is H, you know what it means. So defining is very important, guys. Get used to defining a variable. When I say define a variable, that's what I'm talking about. Give it a meaning. I don't want you to just write H is hour. Hours of what? Hours to make 10 million. So now we're still in the planning phase, and think about this for a moment. We're producing 1,250,000 jelly beans an hour. Think of it as, what happened after 2 hours? How many jelly beans am I going to produce?
500.
Okay, it's 2,500,000. How did you get that answer?
Because I multiplied it by
Okay, what happened after 3 hours?
700.
Okay, so you kind of see the deal. What pattern do you see? 4 hours, 5 hours, 6 hours. What do you do each time to get the answer? Multiply. You add it incrementally, or is there a better way to get, what if I say 6 hours right away? What do? You multiply. So isn't it true that whatever jelly beans you produce per hour here, if you multiply that by the number of hours, shouldn't that give you the total number of jelly beans at the end? And how many jelly beans am I trying to make here? 10 million. Look at that. Guess what? I just came up with a plan, an attack plan. And so now my next step is to solve it, right? I came up with an equation for my planning phase, and now I can start solving for this thing right here. Now if I want to solve, how do I solve this? What am I solving for? I'm solving for H. Okay, so you would divide. So I'm going to go ahead and divide by 1,250,000 jelly beans on each side. Are we going to keep the big numbers, or can we do something to the big numbers? Yes. Very good. We can cancel all the zeros that can be matched. So here's 1, 2, 3, 4. That's it. I can cross out 4 zeros. What I end up with is 1,000 on top and 125 on the bottom. 1,000 divided by 125 will give you
4.
what's the answer?
8.
8. 8 hours, right? So, did we have our answer? 8 hours. However, are we completely done? No. So, if we're not completely done, what's the last step here? We check it. So, as we check it, we're just going to erase this for a moment of the planning phase since we're already done. So what you do is you take that 8 hours, you plug that right back into your H here. Take 1,250,000 times 8. Will that give you 10 million? Indeed. So we checked it. We verified the answer is correct. And this is how we attack a word problem. Systematically. Okay. But that's how we do it. Check this next one out. See if you can actually do it. Okay. Look at this next one right here. What's your attack plan? Read, right. So the background tells you a person can type 148 words per minute. That's a lie. I mean, honestly, you're like already pretty fast. You can type like 80 words per minute. Okay, but 148. Okay. Anyway, how many minutes would it take you to type 3,552 words? Okay. So think about this for a moment. 148 per minute. How long would it take you to type in 3,552 words? So, what do you have to define? What's the unknown?
Minutes.
The minute. See? Right here, you circle right away. How many minutes would it take to type that? So, what variable should I use for minute? M. So I'm going to write M stands for minutes needed to type 3,552 words. Okay, we good with that? So I got my definition down for the variable. And then I know that if I type 148 words per minute, after 2 minutes, I can type almost close to 300 words, right? After 3 minutes, after 4 minutes. So I see the pattern that every time I want to find out the exact minutes, I multiply by the minute, isn't it? That should equal to, how many words do I need to type? 3,552. And now, this is the planning. When you start solving for it, you divide by 148 both sides. M now is going to give you approximately what? Oh, exactly. What should my answer be?
B. 24.
24. D. I knew it. Right. And of course, always check your work. Plug it right back into M. Take 148 times 24 to see if you get 3,552 words per minute. Yes?
You get 24.
Yeah, there it is.
We just said the answer.
Okay. Perfect, guys. Very good. Now, Can you translate this for me? It's going to be quick. Read the sentence and translate it. How do you translate the perimeter of a square equals to 4 times the length of the side?
Whoa.
Whoa.
4 times 4.
The perimeter of a square P equals
P, okay. He said something. P equals the perimeter of a square equals, there it is, equal. So P stands for?
4 times L.
Okay.
4 times 4.
4 times L.
4 times 4?
4 times L.
Oh yeah.
4 squared times
No,
L
of a
squared.
square, not square.
This is a formula, a rule that applies to any square, right? If you tell me to take 4 times 4, are you telling me that it only applies to a square of 4 by 4?
Wait.
What are you talking about here? When you say 4 times 4, that's 16. That applies to just one square. When we talk about a formula, it should apply to any square. What are we doing here? 4 times
L.
L, okay? Or can we just use S for side?
Yes.
Because we are multiplying by side? So what you need to do is, once you have this, you need to define P is the perimeter, right? And S is the side.
Side.
Gotta have a definition for what you're using. You can't just blindly put that there and expect people to understand what S stands for and what P stands for. Okay? So, give it a definition. Give this a definition. Which one fits the description here?
A.
Who said A?
No, wait.
See? Read the problem. A involved the sum, addition, right? Do I see any addition or a sum here? No. What I'm saying is the product.
C. B.
Okay?
Normally.
See? Okay, look.
B.
Look. Listen carefully before you finalize your answer. It's about products. It involves pi. It involves the square of the radius. You know how to write the square of a number, right? A number squared. That's what it means. A number squared. That's what you should be seeing. The square of the radius means that. For those of you who picked this, do you see any square in there?
No, you just see it too.
Of course not. So what is my actual answer to this one?
B.
Yes, indeed. It should be B. Okay? Good. Moving on. Can you translate this? Meaning you verbalize it to me right now, please. Go ahead. Someone. I'm sick. I'm at home. You're going to call me and try to help me write this problem down. Can you help me with that? Yeah. Daddy, just read it. Go out loud. Loud.
Like read that.
Read that. Yeah. How would you say that over the phone to your friend?
12 minus 2 times x equals -5.
Very good. Notice he did not say 2x. He said 2 times x. I love that. He said 12 minus 2 times x equals -5. Okay? Perfect. Any question on that?
Can you use something else like
Yes, of
2
course.
and the product? 12 minus the product of 2 and x?
Oh yeah, 12 minus the product of 2 and x equals to -5. Absolutely. Or if you want to be fancy and you don't care about your friend's feeling because he doesn't know any of this yet, and you want to say something like this, the difference of 12 and the product of 2 and x equals to the opposite of 5.
That's what I was gonna say.
You know? Yeah, that's what you're going to say, right? Like, great, great. It's good. It's good. I love that.
Say that
However,
again,
you can also say it in the simplest way as well, okay? That's verbalizing. Any question on that one? Okay. All right. Can someone verbalize that one?
Oh, I got
Shh. All right, Silvana, go ahead.
The product of B and B plus a. No. I forgot this. 3 times B plus a squared equals 6 divided by. No, I
Okay, Brandon, go ahead.
A squared
Uh-huh.
He stole my idea.
plus 3 times B
Good.
equals 6. Oh wait, C divided by 6.
You just keep.
Indeed. There it is. Simply put it. Right? It's not hard. Why do you have to make it hard for, you know? Look, please. You gotta feel for your friends. He's sick. He can't hear you. You gotta make it loud and clear, right? And now you're twisting your words and make it difficult. You're not helping out. Okay. All right. Translate this for me.
Whoa.
All right. Just hold your thought. I'm gonna ask you to yell at once. Tell me it's A, B, or D, right? Now I'm gonna give you a signal to tell me. But think about that. I'm gonna give you about 5 more seconds. 5, 4, 3, 2. I have to wait. D, you said, and indeed it is D. Very good, perfect. 12 divided by B minus 4 equals to -1. I mean, it's pretty simple, right? Okay, perfect. Can someone translate that? Wait, just go ahead, think it through. You have 5 seconds to think about it. 5 seconds to think about it. Ready?
C.
Wait.
A. C.
Oh, no. Okay, so I'm hearing people yelling A and all that. Listen carefully. Shh. This is not 5 plus A. It's 5 times A, right? And this is B squared plus 1. And of course, the only thing that has that here is C. Read the equation carefully before you convert it. Okay. Check this one out. I have a problem for you.
Whoa.
Now, I want you to come up with a story to describe what's going on. Okay? So let's read this through carefully. F stands for what? That's my prize. F, 1 plus 150 is? Okay, let me ask you this question. Which one costs more? Burger. Okay, here's a trick question. If my burger costs $5, how much is my fries? $3.50. Very good. If my fries cost $2, how much is my burger?
50 cents. Wait, no.
Oh, I tricked you.
No,
If my fries cost $2, how much is my burger?
$3.50.
$3.50. So you can kind of see the relationship between the burger and the fries. Now look, the burger. Okay. Now, look at this equation right here. I do not want you to tell me, oh, it's 4 times the sum of F and 150 minus F equal to 825. That's not what the story I want to hear. But instead, I want to hear something like this. 4 times the price of the burger, because, right? So 4 times the price of the burger minus the price of the fries will equal to $8.25. That's the story I want you to tell me. Is that hard? Alright. But that's what it is. Question on that one. Is this too hard? Now describe this next story to me, please.
Alright, I can describe. Whoa.
Oh, no.
Hey, hear me out. I love saying the name.
Oh, I got the
H stands for height. H minus 3 stands for Consuelo. Alright, so wait, who's taller? Sienna's or Consuelo?
C. C.
No, I'm not. I'm not asking you to tell me the answer.
It's C.
I'm merely asking you to see who's taller. Is it Tiana or Consuelo? Tiana's taller. All right, fine. By how many inches?
3.
By 3 inches. Okay, good. Based on this equation right here, can you describe what's happening?
It's on the top person.
What's this? No, you tell the name. Read the name. Consuelo. This is Consuelo, right? Consuelo's height times the what here? What's 3H represent? Times 3, right? So 3 times Tiana's height times Consuelo's height equals to? So tell me, what should be the answer here?
C.
C, you said.
Yeah.
Oh. Wait. Listen. For those of you who picked C, you did not read this through. This one clearly said the sum. Do you see the sum here?
What's the sum of the product?
Sum means adding.
What's the product?
Product means multiplying. Hello. Difference means minus, and of course addition means, and multiplication means divide. We are not through yet. Listen. Okay, so that's the end of our lecture today, but I do have focus question for you to look at, so here we go, okay? Hold on.
Is there homework today?